Every once in a while, a single idea drops that just changes, well, everything. In the world of AI, that moment was in 2017. It came from a research paper with a title that was honestly a little bit cheeky. Today, we're cracking open that very paper. Attention is all you need to get to the core of the one elegant concept that kickstarted the AI revolution we're living through right now. Let's do it.
It's a pretty wild thought, isn't it? That every time you interact with a sophisticated AI, you're really seeing the ghost of this one paper. We're going to peel back the layers and look at the secret origin story of the tech that is literally reshaping our world as we speak.
Okay, so to really get why this paper was such a lightning strike, we first have to understand the problem it solved. See, before 2017, AI language models had this huge, fundamental problem, a bottleneck in how they thought. Think about reading a super long, complicated sentence. The models they used back then, mostly these things called recurrent neural networks, or RNNs, had to read it just like us, one word at a time, in a straight line. The problem was, by the time they got to the end, they'd often kind of forget the crucial context from the beginning. And this slide just lays out the problem perfectly. Going word by word wasn't just slow because you couldn't process things in parallel, it also made the models forgetful. The paper points out that because it's all sequential, it gets really hard for the model to learn the connections between words that are far apart. This was the wall AI research had basically run headfirst into.
And then came the breakthrough. The authors of this paper asked a really radical question. What if we just threw out the whole one word at a time thing? What if a model could just look at the entire sentence all at once?
And they gave this idea a name, self-attention. So instead of this slow, linear march, self-attention lets the model weigh the importance of every word against every other word all at the exact same time. It can instantly see the entire web of relationships, no matter how long the sentence is.
So how does this magic actually work? Well, the paper breaks it down into this system of queries, keys, and values. Think of it like this. One word, that's the query, basically shouts out to the rest of the sentence, hey, who here is the most important for understanding me? Every other word holds up a key, which is like a little sign describing what it's about. The model then scores how well the query matches all the keys and uses those scores to mix together a new, super context-rich version of the original word. That's the value.
Now, this is where it gets really clever. They supercharged the idea. What you're seeing on the left is that core attention mechanism we just talked about. You can even see the Q, K, and V going in. But they didn't stop there. On the right, you see what they called multi-head attention. It's brilliant. It just runs that same process 8 times in parallel. It's like asking the sentence for context from 8 slightly different points of view all at once, which gives the model this incredibly rich, nuanced understanding.
So this powerful new component, multi-head attention, became the engine for a totally new kind of model. And they gave it a name that would become legendary, the transformer. Let's take a look under the hood.
And here it is, the diagram that basically redrew the map for all of AI. Now I know it looks complex, but the big idea is actually pretty straightforward. On the left, you've got the encoder. Its only job is to read and understand the sentence you give it. On the right, the decoder. Its job is to take that understanding and generate the output. And if you look closely, you'll see those little boxes labeled multi-head attention. Yep, there it is, the secret sauce, right at the heart of the whole machine.
So the key is how they split up the work. The encoder, which is actually 6 identical layers stacked up, just chews on the input sentence over and over until it has this really deep understanding. Then the decoder, also 6 layers, starts generating the new sentence, but it's constantly looking back at 2 things: what the encoder figured out and the words it itself has just written.
Okay, so the theory was beautiful, the architecture was elegant, but the real question is, did it actually work? Well, the authors put the transformer to the test on one of the hardest problems around, machine translation, and the results were just absolutely staggering.
This little table from the paper just nails the why. With the old models, connecting 2 words that were far apart got harder the longer the sentence was. That's what O of n means. But with self-attention, the distance is always 1 step. It's O of 1. That means the model can connect the first word of a book to the last word just as easily as it can connect 2 words sitting side by side. That isn't an improvement. That is a fundamental game changer.
So, what did that game-changing theory mean for performance? Well, on a standard test for English to German translation, the transformer hit a BLEU score of 28.4. Just think of a BLEU score like a grade for how good a translation is. Higher is better, more human-like.
Now, 28.4 might not sound like a huge number, but trust me, in the world of machine translation, this was a seismic shock. This wasn't just a tiny bit better. It was a leap of over 2 full points above the very best systems out there. Systems that were often these clunky, expensive combinations of multiple models. And the transformer did it, as the paper says, for a fraction of the training costs. Better, faster, and cheaper.
So you see, this wasn't just about building a better translation model. It was a whole new blueprint for how to build AI that truly understands language. The shockwaves from this paper would go way, way beyond what anyone could have imagined in 2017.
You know, reading the conclusion of the paper now, it's almost funny how humble it is. The authors just say they're excited about the future and plan to try it on other things. It's like they handed the world the keys to a supercar and just said, "Hope you have fun with this."
And that is exactly what happened. This architecture, the transformer, it became the blueprint, the absolute foundation for pretty much every single major large language model that came after it. From writing your emails to generating code, the family tree of today's most powerful AI tools traces directly back to this one paper.
It all came from just one simple, yet powerful idea. What if you just let the model look at everything at once? It just goes to show you, sometimes the biggest revolutions don't start with more complexity. They start with a simpler, better way of seeing things. It really makes you wonder, doesn't it? What's the next one gonna be?